Hi everyone, I am Madam Rosmaya. Welcome to my YouTube channel. In this video, we are going to discuss on Radii of orbit in Bohr model. A hydrogen atom consists of an electron charge E orbiting a nucleus charge positive E as shown in the figure. So the electron is moving with a tangential speed in an orbit of radius r. When an electron moves around the nucleus, the centripetal force is provided by the electrostatic force. So we can write as centripetal force equals to electrostatic force. Centripetal force is given by mv squared per r. M is mass of electron, v is speed of the electron, and r is radius of the end orbit. Electrostatic force is given by E times E per 4 pi epsilon naught Rn squared. E is the charge of electron or proton, epsilon naught is the permittivity of free space, and H we are going to use later is the Planck's constant. So we rewrite this equation as V squared equals to E squared per 4 pi epsilon naught m Rn squared. Because Rn we cancel out, so becomes Rn. So we call this equation as equation 1. From the periodic table, H has a value of Z1. So that's why for the proton, we have 1e here. So we use Bohr's first postulate. First postulate of Bohr's mentioned that angular momentum is equals to nh per 2 pi. And angular momentum is equals to mvr. So equals to nh per 2 pi. So squaring both sides, we get m squared v squared r squared equals to n squared h squared per 4 pi squared. So we call this equation as equation 2. Next, we use simultaneous equation, substituting equation 1 into equation 2. So the v squared here is e squared per 4 pi epsilon naught mrn. And Rn is equals to, so we cancel the one of the m here, and then pi, one of the pi, and 4, and also one of the r. So the equation becomes Rn equals to epsilon naught n squared h squared per pi me squared. So this equation shows that electrons can only orbit the nucleus at only certain distance, because n is a discrete value where n start from 1, 2, 3 and ... So the radius of the smallest orbit equals to r1 where n equals to 1. So we substitute 1 into here, so we get r1 equals to epsilon naught h squared per pi me squared. So we substitute the epsilon naught h, pi, m, mass of the electron, and charge of the electron into the equation here. So we get R1 equals to 5.31 times 10 to the power of negative 11 meter. So this is radius of the electron for the first orbit in the hydrogen atom. So this radius of the smallest orbit for the hydrogen atom is called the Bohr radius. For N2, we substitute n equals to 2 into the equation here. We have epsilon naught 2 squared h squared per pi me squared, and epsilon naught h squared per pi me squared here is the R1. So the equation for R2 becomes 2 squared R1. For R3, we do the same where n equals to 3, so we substitute here. Then epsilon naught h squared per pi me squared is equals to R1. So the equation here becomes 3 squared R1. And the equations the conclusion for the equation here will become Rn equals to n squared R1. Okay, now for the next orbit, we can calculate the radius using this equation, because the constant value, all constant value here is keep on repeating for n2, n3, and so on. So for n1 is for n1 R1 is 5.31 times 10 to the power of negative 11 meter. For n2, R2 is 2 squared times R1. So we substitute R1 into here. So we get 2.12 times 10 to the power of negative 10 meter. And for n3 equals to 3 squared R1. So becomes 9 times 5.31 times 10 to the power of negative 11. So we get 4.78 times 10 to the power of negative 10 meter. So the radius of R1, R2, and dot 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 for each orbit can be calculated using Rn equals to n squared R1. Okay, this is equation for the radii of orbit in Bohr's model. Bohr's model of the hydrogen atom can also be applied to other atoms with one electron. For example, the singly ionized helium atom He+, the doubly ionized lithium atom Li2+, and the triply ionized beryllium atom Be3+. So the derivation for Rn, earlier are still valid with one modification. All E squared term in the formula are replaced with Ze, where Z is the atomic number of the single electron atom. So we can write like this: Z epsilon naught n squared H squared per pi m Ze squared. So Bohr's model of the atom fails in the case of atoms with more than one electron. So how to get this? We use the same method as before. We use the concept of the circular motion, where the centripetal force is provided by the electrostatic force, and the second equation comes from the first Bohr's postulate, and we combine these two using simultaneous equation. So we get Rn equals to n squared H squared epsilon naught per pi m Ze squared. So that's all for the video. Thank you for watching, and don't forget to subscribe my video if you like the video.